Good day, class. So you are welcome to the maths class. So we'll be looking at some of the JAMB past questions. We are starting from the latest year, that is 2019 question. Question number 1. The radius of a cycle is given as 5 centimeters, subject to an error of 0.1 centimeter. What is the percentage error in the area of the cycle? We need to be very careful about this question. The first thing we need to note in this question is that we are given the radius of a cycle and not the area of a cycle. And also, you are also asked to calculate the percentage error. The first thing is to note, solution, percentage error is equal to the error divided by the actual value times 100 over 1. This is the formula to calculate your percentage error. Now, we are only given the radius, and meanwhile we are asked to calculate the percentage error of the cycle. So we need to note, what is the area of the error? Remember, we are dealing with a cycle. The area of a cycle is pi r squared. Pi r squared. Where this r will represent the radius of the error. So we can calculate this. Pi, the radius of the error in this question is 0.1 centimeter, then square. This represents the area of the error. Now the area of the actual value will now be pi r square also, which will be pi into bracket 5 then square. This represents the area of the actual value we have there. But the question is to calculate the percentage error. Now, the percentage error now be the area of the error, which is pi into bracket 0.1 square divided by the area of the actual, which is pi divided by 5 everything square times 100 over 1. Now, pi, we eliminate pi. So we have 0.1 square. 0.1 square will give us 0.01. Times 100, it will give us 1. That means we are going to have 1 divided by 5 square will give us 25. So the answer becomes 1 over 25. And that is option A. So option A is the correct answer here. So let's move on to question number 2. Question number 2 goes thus. Find the sum of the infinity of the following series. 3, 2, 4 over 5, 8 over 9, 16 over 27, and it continues. Sum to infinity. Solution. The formula to sum to infinity is A divided by 1 minus R. Remember, this topic has been treated before in our previous videos when we are treating series and sequence. So you can go back to our previous videos to understand this topic more. Now, this is the formula to calculate the sum to infinity, where your A represents the first term and R represents the common ratio. Now, your A, which is the first term here, represents the first value that's appearing first, which is 3. So that is your A. A is 3, while your R, common ratio, means the second over the first, which must also be the same thing as the third value over the second. So from here now we can say it's 2 over 3. 2 over 3. Now, since you now know your R and you also know your A, so you can calculate your sum to infinity. So therefore, sum to infinity now becomes A, which is your 3, divided by 1 minus R, and your R is 2 over 3. 3 divided by 1 minus 2 over 3 becomes 1 over 3. Now, 3. If this divide change to times, 3 will come up, the 1 will come down. Becomes 3 times 3 will give us 9. It means the sum to infinity is 9. And that is option D. Now, that is question 1 and question 2. So we now move on to question 3. Now this is question 3. If the binary operation star is defined by m's operation n as this, for any real number m and n, find the identity element e under the operation star. Solution. Now, E represents your identity element. Your M operation, your identity element, remains your M. Remember also, this topic has been treated under binary operation, which is a full topic in our previous video. So let's continue. Now, this is the first, you can call this one equation 1. Now, you can also interpret this following the operation. Interpret this, M operation E. Now, we want to interpret this using the operation. It means anywhere you see M, you keep M, and anywhere you see N, you replace it with E. So it becomes M, E, plus N, plus E. So we call this equation 2. Both equation 1 and 2 are equals to this operation. It means we can equate the two together. That means we can say therefore now, M, which is this M, is equals to this. M, E, plus N, plus E. And the question is to find E, which is the identity element. So we can make E the subject of the formula. So we can transfer this M to this side of the equation. So it becomes M minus M equals to ME plus E. M minus M will give us 0 equals to here. E is common, so we can bring out E, then M plus 1. Now we factorize E out because it's common here. If you bring it out, you are left with M, here you are left with 1. If you open this bracket, you are going to get this back. Remember, we have to find E. To find E, we divide both sides by M plus 1. So we divide both sides by M plus 1. M plus 1. This eliminates this. Now, 0 divided by M plus 1 remains 0 equals to E. Therefore, our identity element is 0. And that is option D. Now, question 4. We are given this figure. If XZ is 10 centimeters, we have to calculate AY. Now, look at this figure very well. Remember that your YZ from here, from this relationship here, we can see that YZ solution, we can see that YZ is equals to AY plus AZ. Meaning that if you can get your YZ and you can get your AZ, then you can get your AY. That is the meaning. So you can continue on the other side of the board. So let's continue here. Now, if this is your right angle triangle, so we can consider triangle XAZ. Considering triangle XAZ. So if you pick out that triangle, this is 30 degrees, this is A, this is Z, this is a right angle, and this is 10 centimeters. We can find our AZ from here. We can find AZ. That is 10 30 will be equals to AZ divided by 10. Do you remember our SOHCAHTOA in our trick? SOHCAHTOA. This topic has been treated before in our previous video, so you can check that more to understand the topic better. Tan. Tan is opposite over adjacent. Opposite over adjacent. That is tan. That's 10 30. Opposite over adjacent. If you cross multiply now, our AZ will now be 10 tan 30. 10 tan 30. And 10 tan 30 using insert form, tan 30. This is root 3, this is 2, and this is 1. From here, remember this is angle 60, and this is the right angle from the trick we've treated before. So tan 30 from here, tan 30 will be 1 over root 3. That is the meaning, tan 30. Meaning that the AZ from here now will now be 10, tan 30 is 1 over root 3. times 1 over root 3, which is 10 over root 3. And that is our AZ. Now we've gotten AZ, we can also find YZ. To find YZ, we need to consider the whole shape. This is 15 plus 30 to make 45 degrees. Considering the whole shape, that means we can also use trig here. Opposite over adjacent. That means we also have 10, 45 this time around. From the full shape to be YZ divided by 10. Where YZ, if you cross multiply, becomes 10 tan 45 degree. This 30 degree. Now, tan 45 degree. Now, tan 45. (45 degree), this is 1 root 2. Tan 45 degree is 1. Tan is opposite over adjacent. So tan 45 is 1. This becomes 10 times 1, which is 10. Now, we've gotten YZ also to be 10. We can now find our AY. So AY from here will be YZ minus AZ. Therefore now, our AY will now be equals to YZ, which is 10, minus AZ, which is 10 over root 3. So this is what we have. But if you look at the option, it seems the 10 has been factorized. So let's factorize this. 10 is common, you bring it out. You are left here with 1 minus 1 over root 3. And this is the end of question number 4. That means option B is the correct option here. So we continue.